Hello and welcome to Dr. Anima Upadhyay's Chemistry and Technology lecture videos. In today's video, we will learn about fullerenes under nanotechnology. Before I start today's topic, I would like you to please subscribe to my channel if you have not done it so far, and to also share this video among all your friends and colleagues. So let's begin with today's topic, the fullerenes. What are fullerenes? They are allotropes of carbon whose molecules consist of carbon atoms connected by single and double bonds so as to form a closed or partially closed mesh with fused rings of 5 to 7 atoms. They could be of shape of a hollow sphere, an ellipsoid, a tube, or it could be in any other different shapes and sizes, as you can see in the figure below. How many types of fullerenes are there? State the smallest and the largest fullerene. There are three important types of fullerenes: C60, C70, and fullerenols. That is C60OHX. The smallest has 20 atoms, while the largest has 540 atoms. How many major families of fullerenes are there? State the differences. There are two major families of fullerenes. One is the closed buckyballs and second is the open-ended cylindrical carbon nanotubes. They have fairly distinct properties and applications due to their structures and bonding. So now we know what are fullerenes, their types, and the number of atoms present in the fullerene molecules, also the major families. So now let's discuss about the various allotropes of carbon and their dimensionalities. So there are many allotropes of carbon such as graphite, which is three-dimensional, graphene two-dimensional, carbon nanotube one-dimensional, fullerene zero-dimensional, and diamond three-dimensional. Does the allotropes of carbon have different physical and chemical properties? Yes, they have different physical and chemical properties, and this is due to the difference in the bonding pattern among their carbon atoms. What is an allotrope? Define. Allotropes are chemical elements that exist in two or more physical forms. Since the allotropes are made up of same element, so the number of protons and neutrons are same, but they may differ in their physical and chemical properties. How are fullerenes prepared? Also state the techniques for preparing fullerenes. They are prepared by heating graphite in an electric arc in presence of an inert gas like helium or argon. There are three main approaches to prepare fullerenes. First is the carbon evaporation method, second is the incomplete combustion of benzene in oxygen, and third is the microwave method. Who won the Nobel Prize for the discovery of fullerene and when? It was in 1996 that Robert Curl, Harold Kroto, and Richard Smalley won the Nobel Prize in Chemistry for the discovery of fullerenes. What is a fullerene made up of? It is made up of carbon molecules arranged in a spherical shape resembling a geodesic dome. What is geodesic? It is the shortest possible line between two points on a sphere or a curved surface. The term geodesic is generally used in geometry. Is fullerene a 100% carbon molecule? Yes, fullerenes are entirely composed of carbon. How are fullerene molecules identified? They are identified as molecules of Cn, where N is the number of carbon atoms in the fullerene molecules. For example, in C60, C70, and C84. 60, 70, and 84 is N respectively. Why C60 is called fullerene? They are called fullerenes after the American architect Richard Buckminster Fuller, who was renowned for his geodesic domes based on the hexagons and pentagons. Depending on the number of hexagons, molecules of different fullerene sizes were obtained. Are fullerenes natural or man-made? And which is the most stable fullerene? Fullerenes are man-made allotropes of carbon and are synthesized under inert conditions at very high temperatures and pressure. C60 is the most stable structure among all the fullerenes. How is C60 fullerene different from C70 fullerene? C60 is like a sphere with a mean diameter of 0.71 nanometer, while C70 is like a rugby ball with a short axis of 0.712 nanometer and long axis of around 0.796 nanometers. What is the first known fullerene? The first known fullerene was a spherical C60 Buckminster fullerene. When was C60 fullerene discovered? It was discovered in 1985. Where is fullerene found in nature? They are found everywhere in the universe. It is also found in the interstellar dust and in the meteor rocks. What is C70 fullerene called? The C70 fullerene is also called rugby ball because of its appearance resembling the rugby ball. Are CNT also fullerenes? Yes, they are cylindrical fullerenes. They could be closed or open-ended. What is spherical and cylindrical fullerenes called? The spherical are called buckyballs and the cylindrical fullerenes are known as nanotubes or buckytubes. How many carbon atoms, pentagonal and hexagonal faces present in the Buckminster fullerene? It contains 60 carbon atoms, 12 pentagonal and 20 hexagonal faces in a hollow spherical cage. Why fullerenes are insoluble in water? Fullerenes are non-polar particles, whereas water is polar solvent. Therefore, they are highly insoluble in water. And this aqueous insolubility also limits to its medical applications. What are fullerenols? Hydroxylated fullerenes are called fullerenols and are denoted by C60OHX, where X is the number of hydroxyl groups attached to the fullerene unit. Are fullerenols water soluble? Yes, they are most promising water soluble derivatives of fullerenes. Why fullerenols are gaining importance? The water solubility and non toxic nature makes fullerenols promising for the use in the various biological applications. They are the main precursors of fullerene based materials that shows unusual biocompatibility and biofunctionality. They help in reducing oxidative stress by scavenging, that is, removing the free radicals that are used in chemotherapy. Are graphene and fullerenes same or different? Graphene and fullerenes are different allotropes of carbon with unique properties and potential uses. Graphene is a single layer of carbon atoms, while fullerenes are balls or tubes made up of carbon atoms. State the physical and chemical properties of fullerenes. The physical properties includes the behavior and structure of fullerenes, that is temperature dependent. With rise in temperature, they get transformed or changed. The structure of fullerenes also changes with change in pressure. The ionization enthalpy of fullerene is 7.61 electron volts. It shows 2.6 to 2.8 electron volts electron affinity. The chemical properties involves that the fullerenes are stable but not inert. That is, they are chemically active. In chemical reactions, they act as an electrophile. It acts as an electron accepting group, that is, as an oxidizing agent. When it is doped with alkali or alkaline earth metals, they show superconductivity. They are generally ferromagnetic. Some fullerenes are chiral. They are soluble in organic solvents but are insoluble in water, except for fullerenols, which are soluble in water. Why is Buckminster fullerene called buckyball? The closed fullerenes C60 are called buckyballs for their resemblance to the standard ball of soccer or football, as you can see in the figure. What are the most important applications of fullerenes? There are many applications of fullerenes which are very important. First, they are used in surface coatings, in molecular networks, as conductors, as absorbent for gases. They are also used as lubricants and as catalysts. They are used in making cosmetic related materials. C60 are used in photovoltaic applications. They are used in CNT based fabrics and fibers. Water soluble fullerenols shows activity against human immunodeficiency viruses. Fullerenols are also used as an antioxidant and in drug delivery. So here we come to an end to this chapter. Thanks for watching it till end.